Yeah, hello and good morning to my day in the life of a HANA administrator. My name is Matthias Sander, and from today in 3 weeks, I'm working with SAP for 20 years. So the 1st of August 2005 was my first day in the SAP Basis department. And the other anniversary this year is 10 years working with the SAP HANA database. So it was quite a long journey until I'm on the stage here. Yeah, today we have a short introduction and the goals for today, and then two real-life cases, two real-life customer cases, which I came over. So it looks like it's all about problems on the HANA database. That's not correct, but for today, it's two problem cases, because I think installing a HANA database is also a day in the life of a HANA administrator, but I think it's not that important for today. Yeah, and as you heard before, we have a very short question and answer at the end. So if you would like to talk to me, I'm at the expert corner, and we have also the lunchtime after this meeting. So what's the goals for today? Yeah, it's go beyond high-level concepts. It's see real-world examples, and to equip you with tools to analyze performance issues or other issues on the HANA database. And at the end, I think it's a little bit more important today than on a audience with only HANA administrators. I try to bridge the gap between the dev teams and the administrators, which brings me to the questions. Who's the dev? Who's the developer? Okay, and the HANA administrator? Oh, it's a little bit more administrators. Perfect. Yeah, that's how my day starts. Since Monday, we just moved into a new house. So normally I came into the room with a nice cup of coffee. And here you can see one HANA feature and one HANA problem. As you can see, this is a 300 gigabyte couch. So normally there should be a 500 gigabyte couch from our old house. And our main entrance, the statement memory limit is 500 gigabyte, but the staircase is a very hard workload class. And this workload class is kept at 300 gigabyte. So the moving people generated a lot of out-of-memory dumps trying to bring the couch up. So if you are interested more into mastering HANA performance workload classes, there will be another slot this afternoon together with Dominic about mastering HANA performance and also workload classes. And the other problem you see here, if you do a select coffee from Coffee Maker, you have to think about my room as a NUMA node, and this is the second floor, and the Coffee Maker is in the ground floor. It's another NUMA node. So if I want to have a coffee, select coffee from Coffee Maker, I have to go downstairs. And this is a NUMA foreign access. So think about of the coffee as the memory. So I have to go downstairs and I have to go upstairs. So I need more time when the Coffee Maker is in the basement. It's the same with the memory access and the NUMA feature of the HANA database. If the memory is not connected to the same NUMA node, you need more time. So maybe you need an example for NUMA access in the future. You can use this one. Yeah, the first case, the customer reported a problem with a specific IDOC type in the system. The normal error description, the process was taking way too long. The next one, IDOC was processed by a background job. And the last one, there are more than one systems involved. That's not very helpful in our case because the problem was located on one system, but maybe sometimes such information is misleading because you're thinking about the network stack and other problems. And yeah, that was all the information we had at the beginning. And they thought it was the HANA database. And at the end, it was the HANA database. So We started to analyze the time frame when the background jobs in the system happens. For this, we used the HANA Global Time Frame report. So many times we will use the scripts from Martin Frauendorfer. I remember the subnode by Woodstock 700. So it's 1969700. So for me, it's the Woodstock 700 SAP node. And for this specific time frame, we only found select for update, so SU, insert, or update statements, which were expensive. So in this case, statements with more than 10 milliseconds were expensive for us in this case, which is a little bit unusual. So normally, if you see a performance problem on the HANA database, most of the time it will be select statements with very complex joins or ABAP managed database procedures. More often, if you have a problem with update or insert statements, the root cause is the disk layer, the network between the storage and your system. So it is maybe more an infrastructure problem if you have too slow enqueue times or anything else. In the next step, we use the statement data collector to check the specific statements we found in the steps before. And with the knowledge we had before, we know the solution. So it's always the same. If you know the solution at the end, it is very simple to solve the error the next time. But to solve it in the first place, you need much more time. So we saw this specific state, call stack not initialized. What's this? So no more information. Normally you get a specific call stack, and there's also a FAQ node where you can look up mostly all of the call stacks which the HANA database is using. And there's also another node where you can look up all the log handles of the HANA database. But in this case, it was only a call stack not initialized. It's a IBM specific problem. So in this case, there's no real documentation about the call stack. That's why this message will be displayed. And the next idea was, why not using the HANA Kernel Profiler? So you can use the HANA Kernel Profiler, as the name says, to trace all the action which the HANA kernel is doing to execute your statement. Until SPS4, I called it mostly via the OS level. But since SPS5, you can use simply SQL commands to call the HANA Kernel Profiler with the variable of the specific statement hash, because it was a very big retailer system. If you call the HANA Kernel Profiler without any variables, you get so much data. There is no chance that you find any useful information from that amount of data. So you can put in a variable with the statement hash. And there we found a very interesting module, the ptime sequence manager. And that brings us, that was the output from the kernel profiler. So when you execute a kernel profiler, you get a text file, and with tools like GraphViz, you find a linked list at the end of every case. You can generate a picture document or a PDF document where you see the flow graph of the statement. And there we have a very important information, wait time over 3 seconds. And if we are going down to detail, there is a sequence manager and wait for next buffer and next val. And that was the main hint at the end to solve the problem. It needed some time until we get there, so it's very simplified on the slides. And based on the information from the kernel profiler, we began to investigating the HANA database triggers and also the HANA database sequences. And also with this information, we had another look at the statement data collector. In the statement data collector, there is a part if a child statement is executed from the root statement. And as you can see there is 90% of the statement execution is a database trigger. And this database trigger is using a sequence. You can see this with the function next while. So this function means I have a sequence. For example, you can start a sequence at 1. You're using the function next while, you get 2, and next while 3, and so on. And all the affected tables, which are involved in this specific IDOC processing, had a database trigger to replicate all DML commands like insert, update, delete to a third-party tool. And the third-party tool is using the sequence in the trigger, as I said before, identified by .next while. And then we checked all the sequences in the system, or all the sequences which are used by the third-party tool, and found out that all these sequences were created with cache 1. So that's slightly or likely the same as a ABAP number range, which is not buffered. You only have one sequence. So if only one record is changed, the next while function gives back one number. But if you're changing 1,000 values at the same time, the next while function needs to execute it 1,000 times, and it needs some times. And that was one of the main reasons why the execution were so slow at this point. And at the end, the solution was, from a technical perspective, from a database or HANA database administrator perspective, was very simple. You can execute a command to change the cache. For example, to 100, to 500, to 1,000. We analyzed all the different tables and how much they would be changed during this IDOC process. So we choose 100 for tables which has a normal change rate, and 500 or 1,000 for tables which has a very high change rate. There might be one problem. There should be, or there could be, the order will fine every time. So the sequence will not be 100 and the next one 99, but there could be gaps in the sequence. So if you're writing the data, or the third-party vendor writing the data to their own table, there might be 90 and then a gap, and the next value might be 100 or 200, depending on the cache size. So you have to check this with your development team or with the third-party tool if it's okay if there is a gap. You're thinking about RW and RF beleg in the ABAP, for example, the Italian solution, it is not allowed to have a gap. So it's strict because it's a text number range, for example. So at the end, the solution from our side was to change the cache side, and the solution at the third-party vendor was to change their code so that the next sequences which will be generated out of the ABAP tool from the third-party vendor will also generate it with cache 100 or cache 500, so that the problem will not occur in the future again. And as we can see, there's a big difference. This screenshot is before, so the normal execution time was around 7 to 8 milliseconds for one insert in this table. And then we can see the IDOC background jobs are starting, and then the answering times are stacking up. And those are only average values. Sometimes it needed more than 4 or 5 seconds only for one IDOC. So if we are thinking of the process as a single thread process, and for example, the average response time is 100 milliseconds, then you can proceed 10 IDOCs per second. So it's not so much if you will proceed 100,000 IDOCs at the end. And this was the after. Here we activated the sequence cache. We changed the sequence cache from 1 to 100 or 500. And then the new response time is under 1 milliseconds. So instead of when we are thinking in a single-threaded application, instead of proceeding 10 IDOCs per second, you can proceed 1,000 IDOCs per second. And at the end, there were many jobs which are running in parallel with a total execution time from over 10 million seconds. And at the end, it was finished in 80,000 milliseconds. So there was a very big improvement. Lessons learned. Over 95% of the time was spending on waiting for the next value, for the next number. So it was in the sequence log. And that's the reason why also the mini checks are very good. So the SID, the 9040, and Martin checks all the caches in the system if there is a cache with only caching demand 1. So if you know the problem, you might solve it much more faster than we solve it in the first place. So you don't need the HANA Kernel Profiler. Maybe you only need configuration mini checks. You see one sequence which has a caching demand of 1. You check all your HANA database triggers where the sequence is used. And maybe based on the database trigger, you found the root cause why someone generated a sequence with only 1. And yes, you should always check your DML statements for triggers. If a trigger is used, you should check the sequences. Yeah, and the trade-off, as I mentioned before, there might be gaps. So you have to check if it is a third-party vendor or your own application, if it is okay that there will be gaps. If not, you have to stay at 1, like the ABAP number ranges, which are not allowed to be buffered. Yeah, as I mentioned before, all the relevant notes and relevant information about the things we saw before. Then it's time for lunch break, pasta and hot coffee. As I mentioned before, in my case, it was not done in 4 hours. It takes us some weeks going back to the third-party vendor, speaking with all the people at the customer and so on. Yeah, but for today, it only needs 4 hours to solve this issue. Yeah, and the second case, customer migrated from DB2 to the HANA database using the software update manager, the SUM, with the database migration option, the DMU option, and a specific transaction runtime increased from under 2 seconds to over 3 minutes. So it's a very, very big difference. Even if we are speaking about 2 seconds and 4 seconds, it's double the response time, but 2 seconds and 3 minutes is a very huge difference. So in the first place, also no more information are available. And I think that's also the important part about today. Many often we only get the information there's something slow in the system. There's something wrong in the system. And if we had more information at the beginning, when we start to investigate the issue, it might be better for us and better for the other side, because we can solve the problems much more faster. For example, the program, if it is ABAP related, so if you know the program, if you know the transaction, if you know the specified line in the program where the statement is called, if you know the background job, or for example, the time frame. So if we have more information at the beginning of the investigation, normally we can solve the information much more faster. Or it will be like a SAP incident, please send me some traces, then send back the ticket and then the new traces, and then you have a little ping pong between you and the HANA database administrator. At the end, what could be the reason for this massive difference? And yeah, we started to analyze the system using the HANA parameter recommendation, and we checked the HANA parameters, so the HANA database parameters. and there were no problem. All parameters were set up fine, especially if you're migrating newly to the HANA database, or if you're executing HANA database upgrade, for example, in the same support package, or an update from SPS 7 to SPS 8, you should always check your HANA parameters, because every time when the subnode 260030 will be updated, it will also update the configuration parameter script so that you can check your system mostly automatically. So you execute the system, you get the list with all the parameters which are not set up according to the subnode, and then you can change it. You should think about every parameter, but then you can change it. Then we checked all the HANA logs, the configuration, the NUMA node configuration, because it was also a new, very big Superdome hardware from HP. So there might be some NUMA node misconfiguration. We checked the HANA load during the execution. We had a meeting together with the tester, with the user. The user executed the transaction. We saw the 3-minute runtime. In this time, we checked the HANA load, CPU, the memory. If you have a pure sandbox system where maybe only one user is testing something, you can also use the script current threads and try to refresh the script current threads and catch the necessary information. But on this system, there were so much testers and so much load, so it was not possible to only catch this one execution. Then we also executed a time frame report. The problem for us was no issues found. So the parameters were fine, the configuration were fine, there were no NUMA misconfiguration, so no problems from a HANA configuration or infrastructure perspective. So in the next step, we started to analyze the problem on the ABAP layer. So that's also one good tip. If you have a problem with an ABAP transaction, generate the ST12 trace before asking your HANA administrator. So one advantage is you can generate it whenever you want, and it is stored in the transaction as a trace. And we have all the data, or mostly we have all the data we need. The screenshots are from the SAP node. They are not from the current case, because I wasn't aware at this date that I needed the screenshots 1 year later for a presentation. So the first thing is you check out the header in the ABAP summary of the ST12 trace, and there's a very good and short information. There's a bar with ABAP time and database time. And if you have a statement which is running 1 second and there's 990 milliseconds ABAP time, then I think there is no need to investigate anything on the HANA database. So only 10 milliseconds from the response times are on the HANA database. But in this case, there's also a color indicator. So green means the lower answering time and red means the higher answering time. And if the database line is the red line, there might be some problems with the database, or it is a good reason to start on the database to investigate the issue. In our case, the database time was dominant, and then you can use the list, and I will always sort it by net time. So the netto time, and then if it is a database procedure, in the last column, there will be the synonym DB for database, and it is underlined, which means you can click on it, and then you get more information about the ABAP program, which is calling this statement, and also the slowest, the fastest, and average execution. So you see the statements in the first only with the bind values, with the question mark. And if you, for example, double click the slowest execution, you will also see the actual bind values, which might be very useful if you want to re-execute the statement in a DBA cockpit to explain it or to visualize it. Yeah, and in the note you find more information. Basically, the note is about how can I use the ST12 to track down a problem on the HANA database, or how can I use the ST12 to decide if the problem is based on the HANA database. And yeah, with the information from the ST12, we found the corresponding SQL on the database. And as we can see here, it was over 3 minutes. So 180,000 milliseconds will be 3 minutes. So it was slightly over 3 minutes. And the statement begins with FDA, so fast data access. And in this case, it was the hint to the solution that we saw the FDA here. Yeah, then you can use, for example, the RSDB6 get source. So just one step back, if you have the caller program on the HANA database, in the first you see SAP LKRRS. So this is the program, and behind this it's the part of the program, and then you can use this other program, the RSDB6 get source, to find the exact part of the source where the SQL statement is originated from. And yeah, it is also possible to find the calling code via ST12. And for the devs, FDA statement on the database is triggered by the ABAP function for all entries. So basically, the ABAP is making the decision if a statement will be executed as FDA, as fast data access right, or not. If the statement is sent to the database as a FDA statement, there is no possibility on the database to change the behavior. It has to be changed in the ABAP. And there's a parameter in the ABAP, the max in blocking factor, which controls when the statement will be sent as an in list to the database or as a fast data access, so as a temp table. So all the bind values will be sent to the database in a temp table. The good thing about FDA is it will always be the same statement hash on the database. And the bad thing about the in list is the standard value for the parameter is 100, which means if you have a temp table with 101 entries, it will be executed as a fast data access write. And if you have less than 100 entries, it will be executed as an in list. But there are 99 possibilities between 1 and 99. So that means there could be 99 different statement hashes at the end on the database. And yeah, so that's what I basically said. If the ETAB is smaller, then it will be an in list. If the ETAB is bigger, then it will be the fast data access function. And yeah, on the database, you see the T_00, which is the temporary table, which is filled from the ABAP side. Yeah, and the recommendation is 100. And that was also the problem here. As the system migrated from DB2 to the HANA database, unfortunately, the ABAP parameters, that's why I said beforehand, we checked the HANA parameters. All the HANA parameters were completely fine at the beginning, but the ABAP parameter, max in blocking factor, has still the value 5, which was the standard value on the DB2, and the DB2 was completely fine to execute the fast data access beginning at 5, but the HANA database is not so good with fast data access and such a small amount of data, as we can see, 2 seconds and 3 minutes. So that was basically the main problem here, because they still used the old application server, which were connected to the DB2 system. After the SUM DMO, they were connected to the HANA database. And in this case, it was, luckily, it was only a sandbox system. So in the productive system, the problem could prevent. Yeah, but here it was in the sandbox system. Yeah, as I said before, for all entries, 5. So it lead to a big performance problem. And that's why you also should check the ABAP parameters. Thinking about the Woodstock 700 node, the 1969700, Martin changed the zip files, the attachments on the node. A few months, or I think 1 year ago, there was one attachment, the SQL statement.zip. And mainly in this zip file, there were all the scripts you need for your daily HANA administrative life. But he splitted the file. Now there is a SQL statement.zip and a SQL statement underscore ABAP. It was the first time after the split I was looking for the ABAP scripts, and I couldn't find them until I found the new attachment in the node. One of the main problems about the ABAP mini check is you need the right to select some tables from the ABAP schema. So, and normally a database administrator should not be allowed to select any data from the ABAP schema. In the best case, only the schema user should be allowed to select data from the ABAP schema, and also the system user should be logged in the system. So normally a good workaround is if you have access to the SAP GUI, you can use the DBA cockpit, and the DBA cockpit, the diagnosis SQL editor. In this case, the DBA cockpit will use the standard database connection, which is the schema user, and then you can execute the ABAP mini check in the DBA cockpit. And one part of the ABAP mini check is the check of all ABAP parameters which are HANA relevant. And in this case, there will be an entry, max in blocking factor is set to 5, please, recommendation set it to 100. So if we know it beforehand and we check the ABAP parameter beforehand, also the same, then we could solve the issue much more faster. Yeah, but sometimes you need a little track to find the solution for a problem. And here we see the before and after. So the first line is always the after line, and the second line is the before line. And after changing it, for all entries had 30 values. So the value is executed as an in list, as works as designed on the HANA database. And now we are down for this specific statement to 40 milliseconds, because the transaction will execute some more statements. At the end, we were under the 2 seconds again, and everyone was happy. And you can also see why the HANA database, or what is one reason why the HANA database needs so long. It's consuming so much resources for the slow execution. If we compare it 31 threads, it's also a lot of threads for one execution, but over 1,000 threads for such a simple execution is too much. That's also a reason why it takes so long. Yeah, the lessons learned from this example is always also check your other parameters, and do this after upgrading your SAP system. So for example, if you're going to a new feature pack, check the other parameters. If you migrate from ECC to S4, check the parameters. So after every upgrade, and also after a kernel upgrade, so maybe with a new kernel stack, kernel standard values will change. So I would check the parameters again. I think that's the main important thing. The fast data access behavior is controlled in the ABAP stack, not controlled on the database. Also a problem in some SCM systems, and WM systems. You have to control it. You should also monitor after update and collaborate across teams, work together. It's not a dev problem. It's not a basis or HANA administrator problem. Speak to your colleagues and try to solve the issue together. Yeah. And also, like the first case, all the relevant SAP nodes and all the relevant links. And for me, this is a wonderful day. But as I said before, at the end, a day as a HANA database administrator could be very different. It's not all about problems. So for me, problems are very interesting because after investigating a problem, I will never forget to check trigger and sequences on a HANA database and how the feature work at the end. It's the same with the SUM process without any errors. Yeah, your system is patched. Very good, cool. But if you have an error between, you know where your trace files are, you learn something about the SAP system. So I think if you have an error and you learn from the error, it's always good for the future. But there might be some architectural things like planning and installation new subsystem, which is also part of our daily life, solving tricky problems like the cases today. Many things about data tiering like NSE, so the native storage extension, and reducing the data amount of a HANA database tuning system, talking to other teams, yeah, and many, many more. So at the end, if the database is running, the customer is satisfied, so am I. It was a cool day. Then for me, a little gaming session before playing with my son. Even if Diablo 4 is out, I also love to play the old one. It's the current season if you want to hop in. Yeah. And to mention at the end, the book from Jens and me about HANA Deep Dive. There are also some much more examples, additional information about HANA workload management, HANA partitioning, how the optimizer works, about the hex engine, hints, and so on. Currently only in German, but English version will follow soon. Jens and I are translating the pictures for now. So maybe at the end of a year, we do not exactly know when the English version will be ready and released, but there will be an English version. Yeah, then thanks for your interest.
Fantastic, Matthias. Thanks a lot for your insights into a day of a HANA administrator. Do we have questions in the audience that you would like to ask towards Matthias and maybe about his day? By the way, I have never heard about the Woodstock note before. So that is something that was very new to me, at least. Any questions? Yeah, there we go. And that was very well handled.
That's that one too. Yeah, thank you a lot for your presentation. I'm wondering, where do you draw your knowledge from? You mentioned a lot of SAP notes. Of course, we have your book to look into, but where do you get your knowledge from? Is it implicitly shared, or what would be your top sources?
If I think back 2015, I started with the HA 200, 210, 250, and so on. And that was also the year when Jens and I get to know. But I think mostly the knowledge is from Dennis Van Kempen, the YouTube channels, for example, then all the wiki things, then the direct contact to the SAP. So, for example, if you have an idea for the scripts, you can write to Martin, and if he thinks it's also useful, then he will implement those things to the scripts. But you can also discuss with Martin about the optimizer problem, because he's from the TPO team or designing the TPOs. Yeah, so I think at the end it's the 10 years, the last 10 years, and reading all the FAQ notes about partitioning, workload management, and all the HANA features. Diving into problems like this. So that's exactly what I said. If everything will be fine every time, you will not learn anything about the deep dive or anything about the features in the HANA database. That's the good thing about errors. Yeah, and then the SAP help other books about HANA. I think it's the answer to the question.
Okay, thank you. Maybe the next step is to build an LLM on your knowledge, and then we can ask you, query your model.
All right, further questions? There's one, yeah.
we all talk about AI and LLMs these days. How does it help in the life of a database administrator? Does it at all?
Yes. So at the moment, we are evaluating, for example, ChatGPT and Perplexity, and I use it anonymized, so I will remove the customer tags or the host names. But for example, if you have a S-trace on Linux, you can take a snippet from the S-trace, put it into the AI, and ask for the error. So beforehand, you have to go on Stack Overflow and all the other sites and look it up by yourself. And now you can use a snippet from the error message. And for Linux, I think it is better. For SAP, it is not so good because Perplexity and ChatGPT, for example, do not have access to the subnodes. But yeah, we will use it in our daily business.
Right. We have more time for questions if there are some. If that is not the case, I'm giving the magical 10 seconds. Then again, Matthias, thanks a lot for being here today.